Hello, welcome on board. Hello, welcome on board. I am Ken Kaner and I will be your host. I coined the term software testing in 1984 and my career is centered around a consistent theme, enhancing the satisfaction and safety of software customers, users, and developers. Testing is the process used to help identify the correctness, completeness, and the quality of computer software. In other words, testing is executing a system or application to find software bugs, defects, or errors. The purpose is to check whether the software satisfies the specific requirements, needs, and expectations of the customer or client. In other words, testing is executing a system. Example: car manufacturers test the cars for maximum speed, fuel efficiency, and safety from the crash. These tests later become part of the advertising strategy for car sales. Test. Hello, welcome on board. I am Ken Kaner and I coined the term testing. The purpose is example: These tests later become part of the advertising strategy for car sales. To uncover errors. Matching product according to software requirements specification SRS, i.e. the product quality and security. To incur minimum cost and effort. Establish confidence in the software. Evaluate the properties of software for functional and non-functional requirement. Testing of software is exceptionally imaginative and an intellectual task for testers to perform. Testing of software or applications consists of some principles that play a significant role in a software tester while testing the project. Let's see these 7 principles one by one. Testing shows the presence of defects. The software testing is aimed at making the program crash. Computer monitoring reduces the likelihood of bugs. Early testing is impossible. This is the method of checking a software's functionality in all possible, valid or invalid, inputs and preconditions. Early testing. To find the defect in the software, early test activity shall be started. Even small modules can contain most of the faults in a project. Pesticide paradox. Repeating the same test cases over and over again won't reveal new bugs. All the test cases need to be checked and test cases inserted or changed to identify new bugs. Testing is context dependent. The testing approach is based on the context of the developed applications. Absence of error fallacy. If a developed software satisfies 99% but doesn't follow the client's requirement, we need to satisfy both the requirements at the same time. A defect could be a variation or deviation from the initial business requirements. What is the bug then? Whereas, a bug is the consequence/outcome of a coding fault. These two terms have a very thin line of difference. Within the industry, both are faults that require to be fixed and then interchangeably utilized by a number of the testing teams. When a tester executes the test cases, he might stumble upon the test result which is contradictory to the expected result. This variation within the test results is called a software defect. It's time to get you motivated. How? Let me. QA Analyst, Fresher. Senior QA Analyst, 2 to 3 years experience. QA Team Coordinator, 5 to 6 years experience. Test Manager, 8 to 11 years experience. Senior Test Manager, 14 plus experience. There are many. ScienceSoft. Capgemini. Wipro. Cognizant. HP. Infosys. TCS. Hexaware. You came this far, hang on for the last part of this section. Software Testing Lifecycle (STLC) is a sequence of specific activities conducted during the testing process to ensure software quality goals are met. Require test planning. Test environment setup. Test execution. Test cycle closure. Each of these stages has a definite entry criteria. Entry criteria gives the prerequisite items that must be completed before testing can begin. Exit criteria. Exit criteria defines the items that must be completed before testing can be concluded. We will be discussing these topics further in our course. I hope you learned something in this topic. By the end of this series you will be ready. Hello there, you are back sooner than expected. Let's continue this quest. Manual testing is a kind of software testing that testers conduct manually without the use of automated tools. Manual testing is a process of finding out the defects or bugs in a software program or system. The tester plays a significant end-user role and verifies that all the application features are running properly. Get fast and accurate visual feedback. It is cheaper because you don't have to spend your budget on automation tools and processes. Human judgment and intuition always benefit the manual element. The manual testing process cannot be registered, hence reuse of the manual test is not possible. Many tasks are difficult to perform manually and can take an additional software test step period. A less effective form of research, as a human, performs it. It is also vulnerable to mistakes and defects. We learned about manual testing, let's see what automation can do. Automation testing means conducting the test case suite using an automation tool. In this method, the test scripts are executed by the testers and automatically produce the test results using automation software. Automated testing relies solely on the pre-scripted test that runs automatically to match real tests with the predicted outcomes. It can easily increase automated testing can help you find more bugs than a human tester. The process of automation may be recorded. This enables you to reuse and perform the same kind of test operations. The tools for running automation testing can be expensive, which will raise the expense of the research project. Debugging the test script is another major issue in automated testing. Test maintenance is costly. Automation tools have limitations that reduce the automation range. The manual testing process is not accurate because of human error possibilities, whereas the automation process is reliable because it is based on code and script. Manual testing is a process that takes time, while automation testing is very easy. Manual testing is possible without knowledge of programming, while automation testing is not possible without knowledge of programming. Manual testing allows random testing, whereas automation testing doesn't allow random testing. It is an iterative development methodology, and the requirements evolve through collaboration between the customer and self-organizing teams. Agile testing can begin at the start of the project with continuous integration between development and testing. Agile testing has shorter timeframes, called iterations. Agile testing saves time and money. Less documentation, regular feedback from end users. Daily meetings can help to identify the problems well in advance. The different principles of testing includes: testing is continuous. Agile team conducts continuous testing, as this is the only way to ensure the product continues to develop. Continuous feedback. Agile testing provides continuous feedback so your product can satisfy business needs. Tests performed by the whole team. Developers, business analytics and testing team, everyone test the application. Decreased time of feedback response. In Agile testing, the business team is involved in every iteration. Thus, continuous feedback reduces response time. Simplified and clean code. In the same iteration, the defects posed by the Agile team are corrected. This helps to keep the code safe and simplified. Less documentation. Reusable checklist, and the team focuses on the test. Reusable checklist and the test-driven. During the time of implementation, one must run tests. We all know very well that nothing works unless we have a proper strategy. We have strategy in sports, business, wars, etc. So what is the testing strategy? Test strategy is a high-level document which captures the approach on how we go about testing the product and achieve the goals. It is developed by the project manager. It is a static document. It is organizationally defined and may be used for other similar projects. The test plan document is a document that contains the plan for all the testing activities to be done to deliver a quality product. It is prepared by the test lead or test manager. It is a dynamic document. On the project level, it is established. Test cases are the collection of positive and negative executable steps of a test scenario that has a collection of preconditions, test data, expected outcomes, post-conditions, and actual results. In a layman language, we can say, test case answers how to be tested. The purpose of the test case is to validate the test scenario by executing a set of steps. A test case may include the elements below. Test case ID, the ID of the test case. Test case summary, the summary, objective of the test case. Related requirement, the ID of the requirement this test case relates/traces to. Prerequisites, any prerequisites or preconditions that must be fulfilled prior to executing the test. Test procedure, step-by-step procedure to execute the test. Test data, the test data, or links to the test data, that are to be used while conducting the test. Expected result, the expected result of the test. Actual result, the actual result of the test, to be filled after executing the test. Status, pass or fail. Others. Remarks, any comments on the test case or test execution. Date of execution, the date of execution of the test. Test environment, the environment, hardware/software/network, in which the test was executed. Let's try to understand with real-time example. Assume that we need to test the functionality of a login page of a Gmail application. Test cases for the above login page functionality as follows. Test case examples. Test case 1, enter valid username and valid password. Test case 2, enter valid username and invalid password. Test case 3, enter invalid username and valid password. Test case 4, enter invalid username and invalid password. Test means verifying or validating, and scenario means any journey with the user. It says verify user journey when combined. Often named test condition or probability of testing. Test scenario gives the idea of what we have to test. Test like a high-level test case. Test scenario answers what to be tested. Creation of test scenarios ensures full coverage of testing. Test scenario is critical for studying the end-to-end functioning of the program. They serve as a fast tool for determining the test work effort and thus establish a proposal for the customer. They help to assess important end-to-end transactions. Let's take an example. Assume that we need to test the functionality of a login page of a Gmail application. Test scenario for the Gmail login page functionality as follows. Test scenario, validate the login page. Test case 1, enter a valid username and password. Test case 2, reset your password. Test case 3, enter invalid credentials. Test case specification document describes a detailed summary of be tested. How they will be tested. How often they will be tested, and so on and so forth. A test plan is a collection of all test specifications. The way to identify a test case in a unique way is as follows. Test case objectives, purpose of the test. Test items, for example, requirement specifications, design specifications, code, etc., required to run a particular test case. This should be provided in the notes or attachment feature. It describes the features and conditions required for testing. Input specifications, description of what is required, step by step, to execute the test case, for example, input files, values that must be entered into a field, etc. This should be provided in the action field. Output specifications, description of what the system should look like after the test case is run. This should be provided in the expected results field. Requirement Traceability Matrix, RTM, is a document that maps and traces user requirements with test cases. It contains all the client's planned requirements and traceability criteria in a single text, delivered at the end of the life cycle of the software development. RTM's primary aim is to verify that all specifications are tested through test cases so that no feature is unchecked during software testing. There are 3 types of traceability matrix. Forward traceability. This is required to check whether the project progresses in the right direction and for the right product. Backward or reverse traceability. The purpose of reverse traceability is to verify that we are not expanding the scope of the project by adding code, design elements, test or other work that is not specified in the requirements. Bidirectional traceability forward and backward. This ensures the requirement covered by the test cases. It analyzes the effect of a change in the specifications of the work product affected by the 100% test coverage. It allows easy identification of the missing functionality. It allows the identification of the test cases that need to be updated in the event of a change in requirement. The overall execution status of tests is easy to monitor. I hope you had fun up till now. At the end of this chapter you will be 50% tester. The waterfall model was implemented as the first system model. Waterfall model is a sequential model that divides software development into predefined phases. In a waterfall model, each step must be finished before the next step can begin so that the phases do not overlap with each other. In a waterfall model, each step must be finished before the next step can begin so that the phases do not overlap with each other. The sequential phases in waterfall model are detailed requirements of the software system to be developed and gathered from the client. System design. Requirements are studied from the previous phase and it helps to define a system architecture. Implementation. The system is designed initially in small programs called units. Each unit is developed and tested according to its functionality. System testing. During this step, you are checking the program to verify that it is built according to the client requirements. System deployment. Once the functional and non-functional testing is done, the product is deployed or released into the market in the client environment. Maintenance. Once your program is ready to use, you might need to change the code later as needed by customer request. In this model, the product is designed, implemented and tested incrementally. Little more is added every time before the product is finished. The product is decomposed into a variety of parts, each of which is individually designed and built. Multiple development cycles take place here, making the life cycle a multi-waterfall cycle. Incremental model allows partial utilization of the product and avoids a long development time. Generates working software quickly and early during the software lifecycle. This model is more flexible and less costly to change scope and requirements. It is easier to test and debug as smaller changes are made during each iteration. It needs good planning and design at every step. Needs a clear and complete definition of the whole system before it can be broken down and built incrementally. Total cost is higher than the waterfall. Spiral model is a combination of a waterfall model and iterative model. Each spiral model process starts with a design objective and finishes with the client reviewing the progress. This model is best used for large projects needing continuous improvement. The same activities are repeated for all the spirals until all of the software is built. Cost estimation becomes easy as prototype building is done in small segments. Development is fast and features are added in a systematic way. There is always a room for customer feedback and the changes are implemented faster. It works best for large projects only and could be expensive for small projects. Risk analysis is an important phase, so it requires expert people for risk assessment. Documentation is more so since it has a large number of intermediate phases. V-model is an SDLC model that has a testing phase corresponding to every development stage in the waterfall. It is also known as verification and validation model. Its development is planned in parallel. So, there are verification phases on one side of the V and validation phases on the other side. The V-model is an extension of the waterfall model and is based on the association for each corresponding development stage of a test phase. This is a highly disciplined model and phases are completed one at a time. Simple and easy to understand and use. Works well for small projects where requirements are easily understood. Very rigid and least flexible, so adjusting scope is difficult and expensive. Software is developed during the implementation phase, so no early prototypes of the software are produced. Not suitable for the projects where requirements are at a moderate to high risk of changing. A prototype is designed to test and try out a new design for system developers and users to improve precision. A prototype is built, tested. Software prototyping models work best in scenarios where the project's requirements are not known. It is an iterative, trial, and error method which takes place between the developer and the client. Sometimes it helps to demonstrate the concept to prospective investors to get funding for a project. It reduces risk of failure, as potential risks can be identified early and corrective steps can be taken. Iteration between the development team and client provides a very good and conductive environment during the project. If too many changes are required in the sample or model product, it can disturb the rhythm of the development team. This methodology may increase the complexity of the system as scope of the system may expand beyond original plans. Congratulations, you are halfway past. But don't quit here, one should never stop learning. We all know about this guy. I don't want to brag about this, but software can earn you billions. Even it did for me. Let's try and repeat this history. Dynamic testing? It is also known as validation in software testing. Dynamic testing software is executed using a set of input values and its output is then examined and compared to what is expected. Inspections, reviews, walkthroughs are involved in this testing. The code must be executed to check the dynamic behavior of the software. Dynamic testing is classified into 3 categories: white box test, black box test, gray box testing. We will discuss both these types thoroughly in the coming chapter. Considered high-level exercise. It can always find errors that static testing cannot find, and that is the reason why it is considered as high-level exercise. Improves quality. Executing the software leads to the chances of finding more bugs in the application. Dynamic, considered high-level exercise. It can always find error. Improves quality. Executing the software leads to the chances of finding more bugs in the application, so it ensures error-free software to some extent. Time-consuming. It is a time-consuming task because its aim is to execute the software, and as a result, more time increases cost of product. It is not done early in the software life cycle, and hence bugs fixed in later stages result in more cost. Execution costly. It requires more manpower to complete the task. Static testing is also known as verification in software testing. Static testing is a software testing technique by which we can check the defects in software without actually executing it. Static testing is performed to prevent early developmental defects, as it is easier to identify sources of failures than failures themselves. Static testing helps find errors which dynamic testing cannot find. Since static testing can start early in the life cycle, early feedback on quality issues can be established. By detecting defects at an early stage, rework costs are most often relatively low. Static tests contribute to an increased awareness of quality issues. Time-consuming as it's done manually. Limited skilled professional to thoroughly conduct code analysis. Functional testing involves testing the application against the business requirements. The aim of functional testing is to verify that the application behaves the way it was intended. Functional checking ensures the program is meeting the specifications properly. Unit testing, individually and independently testing of smallest testable parts of an application. Integration testing, when individual software modules are combined together and tested as a group, then it is known as integration testing. Smoke testing, preliminary testing to reveal simple failures severe enough to, for example, reject a prospective software release or build. Sanity testing, very brief run-through of the functionalities to assure that part of the system or methodology works roughly as expected. System testing, testing conducted on a complete, integrated system to evaluate the system's compliance with its specified requirements. Regression testing, retesting of a software system to confirm that changes made to few parts of the codes has not any side effects on existing system functionalities. Every left has its right. Non-functional testing is designed to figure out if your product will provide a good user experience. The main focus is to improve the user experience on how fast the system responds to a request. Non-functional testing refers to various aspects of the software such as performance, load, stress, scalability, security, compatibility, etc. Performance testing, to evaluate the performance of components of a particular system under a particular workload. Load testing, testing the behavior of the system under a specific load or to get the break-even point where the system starts downgrading its performance. Stress testing, it is performed to find the upper limit capacity of the system and also to determine how the system performs if the current load goes well above the expected maximum. Usability testing, testing to determine the extent to which the software product is understood, easy to learn, easy to operate and attractive to the users under specified conditions. Security testing, this intends to uncover vulnerabilities of the system and determine that its data and resources are protected from possible intruders. Portability testing, software reliability is the probability that software will work properly in a specified environment and for a given amount of time. Black box testing is described as a testing technique in which the application under test, AUT, functionality is checked without looking at the internal code structure, details of implementation and knowledge of the software's internal pathways. In black box testing we just concentrate on software system inputs and outputs without worrying about the software program's inner details. It is also called as behavioral/specification-based input-output testing. The main purpose of black box testing is to check whether the software is working as expected and meeting the customer requirements or not. Let's understand this with an example. In case of Google or any other search engine, the user enters text in the browser. The search engine locates and retrieves the data results. The user is not aware of the source of the process. A black box software tester selects a set of valid and invalid inputs and checks for valid output responses. It is well suited and efficient for large-scale segments. A tester can be non-technical. Highly qualified testers are not required and hence it is less expensive. Tests are done from the user's point of view and are useful to verify the differences in the actual and system and specifications. The coverage is limited since only a selected number of tests are actually performed. As the tester has limited knowledge of the software, the testing is inefficient. The coverage is blind as the tester cannot target specific codes. It is the test method in which the tester is aware of the internal codes and layout of the program. The tester selects inputs and exercises the test by giving the device inputs through the codes and determining the correct outputs. The main focus of WBT is on strengthening the security and on improving the design and usability of the software. How about an example? The white box testing is like the testers are. How about the white box testing is like the working of a car mechanic who knows all the internals of the car and checks why it is not working or giving less mileage, etc. Testing is more thorough, as it covers all possible paths of code. Testers are aware of the internal coding structure, then it is helpful to decide which type of input data is needed to effectively test software applications. White box testing allows you to help in the code optimization. As a highly skilled resource is required to carry out testing who know the deep knowledge of internal structure of the code, the cost is high. If the application under test is large in size, then exhaustive testing is impossible. It is not possible for testing to test each and every path/condition of a software program, which might miss the defects in code. It is the combination of black box testing and white box testing. In the gray box testing, the tester has knowledge of some parts of internal structure. This requires getting access to internal data structures and algorithms to construct test cases. The testing of gray box is considered non-intrusive and impartial as it does not allow the tester to have access to the internal code. Users and developers have clear goals while doing tests. Testers are not required to. By doing gray box testing, benefits of both black box. Gray box testing is unbiased. It avoids conflicts between a tester and a developer. Limited access to internal structure leads to limited access for code path traversal. Because source code cannot be accessed, doing complete white box testing is not possible. Gray box testing is not suitable for algorithm testing. Most of the test cases are difficult to design. You have been a great partner till now. Treat yourself with something sweet. Let's meet in the last quest of. Don't want to face this challenge, then? We have to first understand what is a bug/defect. A programmer can be making mistakes or errors when designing and constructing the software. Such errors or mistakes mean that the program has flaws. Defect life cycle or bug life cycle is the journey of a defect cycle, which a defect goes through during its lifetime. It varies from organization to organization and also from project to project as it is governed by the software test. The aim of the defect life cycle is to organize bug status changes to different assignees easily, and to make the process of bug fixing systematic. What are the defect life cycle states? New, potential defect that is raised and yet to be assigned against a development team to address it but not active. The defect is being addressed by the developer and investigation is under progress. Viz. Deferred or reach. Test. The defect is fixed and ready for testing. Verified. The defect that is retested in the test has been verified by QA. Closed. The final state of the defect that can be closed after the QA retesting or can be closed if the defect is duplicate or considered as not a defect. Reopened. When the defect is not fixed, QA reopens/reactivates the defect. Deferred. When a defect cannot be addressed in that particular cycle, it is deferred to future release. Rejected. A defect can be rejected for any of the three reasons, viz., duplicate defect, not a defect, non-reproducible. SCM is a process to systematically manage, organize, and control the changes in the documents, codes, and other entities during the software development lifecycle. The primary goal is to increase productivity with minimal mistakes. A complete CM program includes provisions for the storing, tracking, and updating of all system information on a component and system basis. An example would be great to finish this topic. Suppose your company develops a third-party aircraft system which includes an LCD screen. The specific LCD screen gets redundant over time, and you need to find a suitable replacement to continue your development. The CM policy will define who is allowed to approve in which organization using another, still compatible, version of the original LCD screen. These 5 disciplines process of CM. Planning and management guides the design of the product, who has what responsibilities, and includes which tools and procedures to use. It identifies third-party requirements and the audit and review process. Identification allows for setting baselines and identifying the configuration of assets and/or software. Control maintain control of configurations, change requests, and execution of changes to a system and its documentation. Status accounting, the process of recording and reporting configuration item descriptions and changes from the baseline over the item's lifecycle. Verification/audit, be able to check what you have introduced and have good control of all managed products. Increased efficiencies, stability and control by improving visibility and tracking. It is helpful to generate the new software with old components. It is helpful to generate the new software with old components. Defining and applying structured policies and procedures regulating asset recognition, status control, and auditing. Good wishes for all your future quests as a tester.